Hey guys, Mr. Backerberg here. In this video, we're going to look at constant percentage rate and exponential functions. If we've got a population that is changing at a constant rate each year, then we can model that with the function p of t equals p sub 0 times 1 plus r raised to the t power. P sub 0 is going to represent our initial population. The R value percentage rate we're going to use as a decimal. And our T value is going to be the time in years. If our R value is positive, then our population is going to be increasing, so we can call this a growth function. But if our R value is negative, that'll mean our population is going down, so this would be a decay function. So in this first example, we're going to look at finding an exponential function. So here's what we're told. We're going to determine the exponential function where we've got an initial population of 12, but that's increasing at a rate of 8% per year. So if we think about our population model, it's P of t equals P sub 0 times 1 plus r to the t power. P sub 0 is our initial population. So as we start writing out this function, that 12 is going to be my initial population. Inside of my parentheses with that 1 plus r, that r is our percentage rate, but we need to convert that into a decimal. So when we're dealing with 8%, that's really 0.08 as a decimal, and this is going to be raised to the t power. And remember, t stands for our time in years. Now, inside of my parentheses, I can take that 1 and add 0.08 to it. So I should get P of t equals 12 times 1.08 to the t power. In this example, we're given a population model, and we want to find the percentage rate of our growth or decay, and then based on the rate that we find, we want to determine if our model is a growth function or a decay function. So we want to think about our general population model. P of t equals P sub 0 times 1 plus r raised to the t power. And as we're focusing on the rate, we're trying to figure out what that r value is. So as we look at our function as a whole, the first number is our initial population. So as we look at this function, that 898,759, that's our initial population. Where we're going to be looking to find our rate is really with this 1.0064 raised to the t power, because inside of our parentheses, that's where our r value is located. So I'm going to look at that 1 plus r as equaling my 1.0064. Now if I subtract that 1 from each side, I'm going to get an r value of 0.0064, and I'm going to convert that into a percentage, so it's 0.64%. Now because our r value is positive, that means our population is going up, so this is going to be a growth function. Now as we look at this example, same idea. We're looking for the percentage rate of growth or decay, and we're going to try to figure out if this is going to be a growth function or a decay function. Just like I did on the last one, I'm going to focus on what the t power is on. That other number isn't very important when we're trying to find the rate of our growth or decay. So I'm looking at the 0.958 as equaling my 1 plus r. If I subtract the 1 over to the other side, I'm going to get an r value of negative 0.0142, which if I convert that into a decimal, this is going to be negative 1.42%. Because we've got a negative r value, that means that this is going to be a decay function, meaning that our population would be going down. That's going to be it for this video. Thanks for watching.